Now we're going to look at something called sampling distributions. We're just going to be exploring variability. Suppose we want to know the proportion of students at a local university who had at least one tattoo. So how can we determine this? Well, we could go around and take a census of everyone on campus, ask them if they have at least one tattoo. However, this would be very time-consuming and nearly impossible. So a more practical way would be to take a representative sample. Suppose that a class of 30 students decides to take on this project. They go around campus to different locations. They each ask 100 students out of a campus population of about 22,000 if they have at least one tattoo. They come back to class and present their findings. So the first student says, out of my sample of 100, 24 had a tattoo. Or the second student may say, out of my sample, 22 had a tattoo. The third one may say, out of my sample, only 18 had a tattoo. And this continues around the room. The teacher takes down everyone's sample count, quickly converts it to a proportion. And we will call and notate this proportion, the sample proportion, p hat. So p hat equals 24 divided by 100, or 0.24 for the first sample. So think of p hat similar to when we were looking at probability. That is, so p hat is the number of successes in the sample divided by the total number in the sample, where a success was having a tattoo in this example. And this can be notated symbolically as p hat equals x over n. And here, everyone's sample proportion is listed in the grid. So let's make a few observations concerning this collection of sample proportions. So one obvious aspect is that there's variability among the different samples. This is called sampling variability. It ranges from a low of about 0.14 to a high of 0.31. Now I want to get a better sense of the shape, center, and spread of the data. We should be familiar with this. We're going to create a histogram and a box plot. I use StatCrunch to do this. There's my histogram. There's my box plot. I note that's relatively bell-shaped and symmetric. Now here I've created a summary statistics table. Again, note we had 30 students that take the sample, hence n was 30. Notice that the mean of all of the proportions is 0.226, and the median is 0.225. This was also reflected in the histogram with a peak of about 0.23. And the spread is best described by the standard deviation of about 0.04. So we only took 30 different samples of size 100. When we look at this distribution of samples, we were attempting to investigate the sampling distribution of all of the sample proportions. So the sampling distribution, it represents the distribution of the point estimates. Here we were estimating the proportion based on samples fixed size from a certain population. So it's useful to think of a particular point estimate as being drawn from such a distribution. So in practice, we don't actually take all the possible samples to develop the sampling distribution. So in this example, there are like 6.9 times 10 to the 97th different possibilities we could have had. So this can be even a challenge for computers. So we actually want to simulate using a significantly smaller sample size to actually approximate this sampling distribution. Let's consider the following example. So suppose we have a bag of Reese's Pieces that has 50% orange, 25% yellow, and 25% brown. And here's how the colors for the Reese's Pieces candies are distributed. So let's find the approximate sampling distribution for the proportion of orange candies